I know. All right. So guys, here you go. Let me help you get oriented. So obviously this is the topic for your notes. Today you're going to learn about a process called titration. Now, here's the thing you need to know up front. This is a laboratory process. So in order for you to understand titration, you have to understand the way that this goes in lab. Now, in order for you to understand the way that this is going to go in lab, guys, we are actually, Diana, going to do the lab today. That's the second time in 2 days. I'm going to kill you, even though you're a girl. And you know that I will, because I already hit Sarah with a ball. Don't think I won't come after you, too.
Oh, yeah.
All right. So, guys, this is the way this is going to progress. What I'm going to do to help you understand this process is I'm actually going to share with you the concept, and it's going to go fast. Then, guys, once you understand the concept, I'm going to give you the steps for the math, and that will eventually enable you to do this, which is the homework, which we'll be grading on Monday, in addition to turning in your Le Chatelier's principal labs if you have not yet done so. Then, guys, this is the way the rest of the day is going to go. We are actually going to do the lab today. Now, guys, this is all of the stuff that you need in order to do this lab. And I'm going to show you how this works. But you are never going to get to lay hands on any of this stuff in this class this year. Guys, what we are going to do, and this is what I'm going to do with you, given these instructions, is we are going to do this lab through virtualization. There's a lab simulation software package that actually I've been a part of the development of since it started about 15 years ago. It is amazingly good, not because of anything that I've done, but because of the work they did at BYU. We are going to use this software to carry out this lab. And guys, that is what you are then going to do on Monday. When you come in on Monday, you're going to grade this homework, and then all you're going to do is go and grab a laptop, and you are going to do this lab without any direction from me, simply based upon what you see up here as we do this together. You get the idea? All right. So guys, with that said then, in order for you to be good at doing titration, and this goes in your notes, you first of all have got to know what on earth is titration. So, guys, the definition is going to sound weird until I show you another practical way that you do something similar. So write it down first. Guys, titration, and I left out the first couple words, is the process of determining the concentration of one solution by comparing it with another. So guys, bottom line is this. Why do we titrate? We titrate to figure out the concentrations of solutions. For us, those solutions will be acids and bases. That's the connection to this lab, or to this unit. But guys, bottom line is this. You have a solution that you don't know the concentration of, and in order to figure out the concentration of the one you don't know, you compare that solution with a solution that you do know the concentration of. So now you're going, wait, hold on. So you're telling me that I can find the concentration of one thing by comparing it with another thing? Yeah. And guys, if that seems weird, try this on for size. Same process right here. How tall am I? Take a guess. No. 6 is not the first number. I used to think I was 5'9". And then when I got fit for my bike, they actually measured me all over the... Turns out I'm 5'8". And you realize what that did, right? It made my BMI go up. So now I'm technically obese because when I was 5'9", my 175 pounds was spread over 5'9", and I was right below obese, you know, the BMI index. Well, now that I'm only 5'8", apparently I'm obese, which makes me question the index. But here's the idea. Guys, if you really wanted to find out how tall I am, you could eyeball and go 5'8", but what you really need is a standard. So guys, this piece of plastic is 1 foot tall. So if you want to know how tall I am, you go bump, 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 and by comparing me to this, you can find out how tall I am simply through comparison. But in order for that to work, you've got to know how tall this is. Well, guys, the same thing happens here. If we have a solution we don't know the concentration of, by comparing it with one we do know the concentration of, we can figure out the concentration of the other guy, just like finding my height. Now, here's the question. It's really obvious how to compare when you're doing height, right? But how do you compare when you're talking about solutions? And the answer is this: react them together. Okay? And that's what you're going to do in lab. You are going to compare by reacting them together. So guys, this then brings us to the next two terms. So we understand that we've got one solution that we don't know the concentration of and another one that we do. Those have names. The one that we know the concentration of is what is called the standard. That would be the ruler, the thing we know something about, whether it's height or concentration. The standard is the solution that we know the concentration of. Then, guys, the other one, the one we don't know the concentration of, obviously that's called the unknown. Now, guys, there's one more thing we need to talk about then for you to really understand this. And it's this. Guys, when, and this you sort of take for granted, but let me help you make the connection. Okay, so the standard is the one that you know the concentration of, and the unknown is the one you're studying. So let's go back to me and the ruler. You ready? So let's find out how tall I am. So we go 1 foot, 2 foot, 3 foot, 4 foot, 5 foot. How do you know when to stop moving the ruler up? When you run out of me, right? So you start here and you go 1, 3, 4, and when you get here, you go, and then you measure my height. But you stop when you run out of me. Well, guys, how do you know when to stop when you're doing a titration? And guys, the answer is this. You need what is called an indicator. And an indicator indicates the point when you've added enough standard to the unknown. Now, how much standard do you need to add? These are acid-base reactions, so the answer will be when it's neutral, when it's pH 7, because then you've added enough base to the acid to completely react with it. So that would be the indicator. Yeah?
Whenever you turn something like that into neutral,
Uh-huh.
are you able to drink it just like water?
No, because remember the idea is that, so if you watch my hands, an acid-base reaction goes acid plus base yields salt and water, right? But we understand, guys, that salts are not just NaCl, and sometimes those salts are poisonous. Yeah, so you got to be careful. Yeah?
I was just curious.
Mm-hmm.
The standard
Yeah.
is usually smaller than that.
What do you mean by smaller? No, that's a good question. Well, it's better if it is, because you get better data if you use larger samples. So typically, that's interesting you picked, that's cool. Typically, you want your standard to be less concentrated than your unknown. But remember, you don't know. It's unknown, so you're really not sure. But like, for example, if you come back for AP next year, because I do know the answers, you'll always be given standards that are less concentrated than your unknowns. Yeah, it's actually a good point, but sometimes you just don't know. So you guys okay? You get the idea? So again, it's a process of comparison. You've got your standard, you've got your unknown, you put them together. When the indicator changes color, you know you're done, and that lets you find the concentration of the unknown. Good? Okay. So the question then becomes, how do you do that? Well, guys, it goes like this. This is the math, and you want to include this in your notes. It's a 4-step mathematical process. Step number 1 is write a balanced equation. Step 2 is calculate the moles of standard. Step 3 is the mole-to-mole ratio of unknown or standard to unknown. And then the last step, the goal, is to calculate the concentration of the unknown. Guys, as you're writing this down, let me whisper in your ears. You have a comprehensive final in 2 weeks, right? The SAGE test. The SAGE test covers all of the material that you've learned this year. And it's a good test. It's tough. It's thorough. So guys, here's what I'm going to do. For the rest of the year, I'm going to start sprinkling what you're doing in class with review for SAGE. And I'll tell you when I'm doing it. But guys, I'm going to look for this because you're going to see this more and more throughout the coming days. So guys, when you're done writing this down, we'll talk about it, and then it's time to do the lab together. Yeah?
For the SAGE test, are there things on the SAGE test that you're going to be teaching after the SAGE test?
No, thank goodness, because that happened to us last year. So it used to be, Braden, that what we would do is the unit that we're currently doing, we did after SAGE, because there wasn't a lot of this on SAGE. And there was a lot of, or on not SAGE, what was it called before? Say it again? CRTs. It used to be there was a lot of gas law stuff on the CRT and not a lot of this. SAGE, they changed it, and it was a horrible experience because we didn't know they were going to change it. When my kids took SAGE for the first time last year, they all came back after the SAGE test and they're like, what the crap is this equilibrium stuff? And it's like, oh, poop. Because guess what we did after SAGE? All the equilibrium stuff. And so what we did this year is we switched it because they took gases off of SAGE. So we switched the units so that this will be on SAGE and gases aren't. So you shouldn't see anything on SAGE you haven't seen. So yeah, okay. It is good to know. Okay, so guys, you ready? How about a little SAGE review, shall we? Remember the idea that acids and bases make salt and water. But guys, salt is not NaCl. NaCl is a salt, but guys, what are salts? A metal and a nonmetal ionically bonded. Okay, keep that in mind. So, you guys got this all written down? You're caught up with me? Okay. Guys, we are now ready to go do the lab. Now, first of all, let's make sure you remember, guys, when we are calculating concentration, what units do we use for concentration? Molarity, right? If you don't remember, not moles, molarity. If you need to write this down, you can. Molarity is moles divided by liters. You okay? Okay, now, guys, here's what we're going to do. We are now going to go do the lab together. As we do the lab, you are going to collect data. So make a data chart. Do this in your notes. Do not collect any data on the lab itself. We are going to make up our own data chart and we're going to collect all of our data here. So guys, these are the 3 pieces of data we need to collect. The concentration of the standard, the volume of the unknown used, and the volume of the standard that was added to the unknown. So once you've got that written down, the only additional notes that you need to take today are the data. Is the data, are the data, will be the data. You're going to write down some data. And then we'll do the math together, but you're done taking notes. You guys ready to go? Again, once you've got this data chart copied down, you can just sort of, but guys, certainly, well, actually, no. What you need to do then is grab the lab, because we're going to do the lab together. So grab the lab sheet that I gave you, and be ready to take notes into the lab. So guys, while you are not recording data in the lab, you will be writing on the lab, and I'll show you what I mean in just a minute. Did you all get it? Kira, did you get one? You're okay? Okay. So guys, here's the deal. What you're going to do now is you are going to learn to titrate. And guys, this is a very real thing. And I'm going to show you how this works. When you come back for AP next year, you will actually do 7 titration labs, all in a row. It takes us about 7 weeks to do all of them. Guys, today and in this year, you are not going to get to use any of this. But I want to show you how this works so that you understand what you will be doing through virtualization. So guys, this is how titration works. In order to titrate, what we've got to do is be able to measure volumes very accurately. And that's where this thing comes in. Guys, these are stupid expensive, $52 each. I just had to buy a dozen of them. That was more than $600. Guys, these are what are called burettes. And the thing that makes them so expensive is actually these markings that are on them. Guys, on a graduated cylinder, these markings, especially if they're glass, are just painted onto the cylinder. And they're close, but they're not perfect. Guys, on a burette, these are actually laser etched into the glass, and they're very, very accurate. That's what makes them expensive. Now, the thing that's weird about a burette compared to a graduated cylinder is this. Guys, where's the 0 mark on a graduated cylinder? At the bottom, right? And up here is 50. Well, guys, a burette is actually upside down. 50 is at the bottom and 0 is at the top. Why would that be true? Well, guys, the reason that that's the case is because you don't pour out of your burette, you leak out the bottom. This is just water. But guys, you actually don't pour out the top, you dispense out the bottom. So the way that this works is anytime the handle is horizontal, the valve is shut off. Anytime it's vertical, it drains out the bottom and you can actually measure how much you're dispensing. Now guys, the thing that makes these very accurate is this. Anytime, there's a puddle, anytime the handle is vertical, horizontal, it's shut off. Anytime it's vertical, it flows. But if you turn this quickly through half turns, you can see it sort of splash. Those are what are called micro drops. And guys, you can actually accurately dispense thousandths of a milliliter with these things. They are amazingly accurate. So what we do is this. When we are titrating, and this is called a burette clamp, when we are titrating, what we do is we put the burette in the burette clamp, and then guys, we fill the burette with our standard. So for our labs, the standard is always going to be the base. So we will put the base in the burette. Then guys, we need a place to put the acid. And what we'll do is this. We will use graduated cylinders to measure the acid, and we will put the acid in a beaker. This is just water. Then, in order to titrate, what you do is you put the acid underneath the burette with the standard, and you put some indicator in here that changes color at pH 7. Then you open this up and you let the base, the standard, drain into the acid until this changes color, and at that moment you know that you've now neutralized the acid and the titration's over. Now guys, in order for this to happen, it's critical that you stir this, and actually it turns out that a stirring rod is not a good enough way to stir this. So you ready? This is going to be mind-boggling for some of you. In order to stir this, this is what you use. This is what is called a magnetic stirring plate. The way that it works is this. There's a motor down inside this base, and attached to the top of the motor is a magnetic bar. These ship with one of these, which is another magnetic bar wrapped in nylon, so that if you're doing this in acids, the acid doesn't eat the magnet. Now, as you'd expect, this magnet is attracted to the magnet underneath the plate. You see where this is going, right? All right. So what we do then is we plug this in, and then we turn on the motor that's down inside the plate, and as that motor spins, the magnet here follows the magnet underneath. Well guys, that magnetic force not only gets through the plastic plate, it also goes through glass. So you put this in here, you turn this on, and it stirs the solution with no physical or mechanical contact between the stirrer and the motor. Pretty slick, right? Now, guys, you think this is magical, wait until next year in AP Lab where you get into your lab drawers for the first time and find out there's one of these in all of the AP Lab drawers, and it's like Christmas in August because you don't have to stir solutions anymore, because every AP Lab that we use that needs to be stirred, you'll use one of these because it's a more effective way to stir. Won't that be fun? All right, this actually 2 years ago, I didn't have the money to buy these for my classes, and a couple of my AP students took the motor off of an old junked computer case, and they taped a magnet to it, stuck it inside a crayon box, plugged it into the wall, and made their own magnetic stirrer. Pretty geeky. All right. Anyway, so there you go. So now, of course, the question, right, is how do you get the bar back out?
No way.
Oh, yeah. There you go. All right.
But you don't want to like touch it.
Well, I mean, no. If this were something corrosive, you would take it out and then immediately just run it under water. Yeah, but because it's water, we were fine. All right, so there you go. So guys, again, those are all of the things that you need. Those are the players, if you will, in titration. Now, guys, check this out. Let me turn out the lights so you can see it. Guys, this is a screen capture from the software we're going to use. They got this right all the way down to the orange valve on the burette. The only difference between this and what we've got is that their stirring plate is gray and white, and I actually have gray and white ones as well. The difference is that this is not just a stir, it's also a hot plate. So it not only stirs, it also heats, and these don't heat. The ones that heat and stir are gray and white. But guys, they got everything else right. They've got beakers, they've got graduated cylinders, they've got the burette. They actually have metallic burette clamps where ours are painted white. But guys, it's all just like the lab. This is actually modeled off the Chem 107 lab at BYU. Then, check out the bottles. So guys, this is the way we're going to do this. Oh, and I didn't mention this. Did I tell you about this software? Guys, this was actually written at BYU. A guy named Dr. Woodfield at BYU about 15 years ago wrote a National Science Foundation grant for several $1 million to pay to develop this software. And then actually he invited me over to campus when he started the software, and he asked me if I and some other teachers would be willing to accept his trial versions before they got released and sort of test it for bugs and stuff like that. So I've actually been sort of one of the beta testers for this software from its inception. Since then, he actually sold the software to a book publishing company, and now they're making lots of money off of it. But anyway, this was actually written at BYU, and it's the best software out there. It's kind of a notch in BYU's belt because they did a really nice job with this. But anyway, guys, with that said, these are what we're going to use for standards and unknowns. So guys, our standard is always going to be sodium hydroxide, our base. Now guys, what is it that makes this the standard? What is the standard? What makes it the standard? You know the concentration. The unknown will be the acid. See the problem? We know its concentration. Guys, it turns out that this software tells you the concentrations of everything. So here's what we're going to do. We are going to pretend like we don't know the concentration of the acid, but in fact we really do. So what we will do is we will calculate the concentration of the acid, then we'll see how close we got by calculating what? Percent error. You got the idea? Okay. So guys, this is what the software looks like. Let me, what's the best way to do this? Let me turn on the light, grab your labs, and we are now going to do this lab together. You ready? We are going to go through the procedure. I am going to share with you all the tricks that make this lab work better. It will be to your advantage to write these things down next to the procedure steps so that you can be successful too. You ready? Here is procedure step number 0. It's actually not there, but you want to write this down next to where it says procedure. Guys, procedure step 0 is this. Turn up the volume. Seriously. When you get the laptop, the first thing that you want to do is turn the volume all the way up. This software is so good that it actually has audio clues about what's going on in the lab. And if you can't hear them, you can't take advantage of them. So step 0 is turn up the volume. Then, guys, step 2 is this. It says, step 1 is launch Virtual Chem Lab. When you get your laptop, you'll crash into the bottom of the screen, and down here you will see, I don't know where it'll be on yours, but it's a purple square that says VCL. So you just click on VCL. Dun, 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 like so. And there's Virtual Chem Lab. Now guys, about 3 months ago, they released a new version of this software, and the new version makes step 2 unnecessary. Cross it out. Step 2 says enter the general chemistry lab. Now the software automatically takes you into the general chemistry lab. So guys, with that said, let me go back here and let me get this doing again what it needs to be doing. Okay, and so now we're back in Virtual Chem Lab. And now guys, as we read on, it says in step 3, choose the titration bench. Okay, so let me just sort of show you what you're looking at from a distance. Guys, there are actually 5 lab benches in this software, and let me tell you about them. And the reason I'm telling you about these is because when you're done with the lab will take you about half an hour on Monday. You'll have about 40 minutes left. Guys, if you want to fiddle around with any of these other lab benches, feel free. It's actually pretty cool. So let me introduce you to them. This one right here on the left is actually the calorimetry lab. You can heat things up, catch it on fire, blow things up. Anyway, it's fire. Okay. Then guys, here, this is the titration lab. This is the one we're going to use. Guys, this bench right here, next year in AP lab, you're going to fall in love with this bench. It's amazing the chemistry that we can do on this bench. We're going to spend a couple weeks here next year. Understand guys, this year, because you don't know enough chemistry, you'll go to this bench and you'll probably quickly get bored with it, but you're going to fall in love with this next year. Now guys, Braden, this is to what you were talking about. Guys, this bench is the gases bench. We are going to do the gases unit after the SAGE test. So this isn't going to mean a lot to you because we haven't done it yet. But guys, this bench is really cool. This is what is called the quantum theory bench. This is all about the structure of atoms. So guys, let's do a little SAGE review. When you learned about the structure of atoms, we talked about some of the scientists that did the experiments that told us about atoms. Like remember J.J. Thomson? What did Thomson do? Cathode ray tube, what did he discover? The electron. And then Robert Millikan did the oil drop experiment. What did he discover? The charge of an electron. And then guys, after that we had Lord Rutherford. Rutherford did the gold foil experiment, and what did he discover? The nucleus of the atom. Guys, you can do all of those experiments right here. It's really cool. Let me show you a shortcut to do them. These are actually pre-prepared labs. So if you go down here and if you click on atomic theory, here's Thomson, Millikan, and Rutherford. You can do, and actually you can do Bohr's experiment with emission spectra. You can do all of those experiments right on that bench just by clicking on them here. So if you're interested in doing that, go for it. It's kind of cool. Anyway, what we're going to do is go to the titration bench. So that was which step? 3. Okay, so now guys, I'm going to turn the lights back on. We're now done with step 3. Step 4 says this, go into the stock room. Guys, right here, this is the stock room. So when you click on that, let me zoom in so you can see it. When you click on the stock room, you now go into this space. And this space has all the chemicals that you're allowed to play with out in the lab. Here's all the acids, here's all the bases. Guys, this stuff down here, the reductants and the oxidants and the inert salts are actually chemicals that you need for a completely different type of titration. You're welcome to fiddle around with them if you want to, but understand this isn't what we're doing. Okay, so then guys, it says this, step 5. Place the nitric acid on the counter. Now guys, I'm not going to do nitric acid because that's what you're doing in lab. So I'm going to grab the hydrochloric instead. But guys, watch how this works. So here's the hydrochloric acid, right? And you can see my mouse. When I put the mouse over the bottle, it turns into a hand, and that obviously means you can grab it. But guys, now watch down here on the counter. When I put the mouse over the bottle, watch what happens on the counter. I put my hand over the bottle, or the thing over the bottle, it turns into a hand. When I click on it, it hands me the bottle and I can move it around. But what happened on the counter? See where it lit up? Those are the only places you can put the bottle. If you try to put the bottle anywhere else, it just goes back on the shelf. So listen carefully. You grab the bottle, put it down, and you'll know that you've done it successfully when it goes. Then guys, step 6 says place the sodium hydroxide bottle on the counter. There you go. And now you've got your two substances. Now guys, just so you remember, we are going to use this as our standard. We're pretending like we don't know the concentration of the acid. This is going to be our standard. So guys, it doesn't mention this in the lab, but you may want to write this down, actually do. Next to step 6, you need to write down, record the concentration. So guys, we are now going to record the concentration of the standard. It is 0.1104 molar. So now guys, go over to your data chart and we are going to record that concentration. It is 0.1104 molar. Okay, so now clear this, go here, skip over to this. All right, so now guys, we're done with step 6, on to step 7, return to the lab. You'll notice there's an arrow right here, and guys, check out what happens. When you go back to the lab, there's the bottle as you just set on the counter, and now here are all the indicators that you could use to do this titration. All right, so now we're ready to go on. Step 8 says this. Bring the bottles into the lab. So guys, what's going to happen when I grab one of these bottles? You're going to get circles. So I'm going to put this one here, and I'm going to put this one here. All right, so now I've done step 8. I brought the bottles into the lab. Now step 9. Mouse over the burette and open the viewer window. Guys, check it out. So when I mouse over the burette and click, look on the left-hand side of the screen. A window opens up. And in this window, it actually zooms you into the burette. And guys, what you're going to find out is that it automatically tracks the level of the substance in the burette. There's nothing in there now, but it will in a minute. Okay, so that was step 9. Now we're on to 10. Fill the burette over the 0 mark with the base. Now guys, watch. This is one of the glitches in the software. So we are going to grab the base and we're going to put it in the burette. So let me zoom in. But guys, here's how you do it. Grab the bottle, and then what you've got to do is sneak up on the burette from underneath. And what you're going to see is that as you sneak up on the burette, the software will actually take the bottle out of your hand, lift it up above the burette, fill the burette all the way to the top, and then put the bottle down. So watch. You sneak up on it, here it goes, it steals it, fills it, and puts it away. Now guys, here's the thing that you didn't know. I had the mouse button clicked the whole time. You need to write that into your lab. Guys, for step 10, hold the mouse down. Just write down, hold mouse down, or hold button down. Because guys, it's not like that for any of the other glassware. The burette is the only one that you fill by holding it down. But now guys, watch. Do you see what changed? What do we call this dip, reviewing for Sage? The meniscus. Where do we measure from the meniscus? The bottom, and it is sitting exactly on the 0 mark, which tells us, guys, that this thing is perfectly filled to 0. Get the idea? That's called zeroing a burette. Okay, so now we're ready to move on. Let me zoom back out. And what is our next step? Step 11. Open the beaker drawer and put a beaker on the lab bench. You ready? Open, close, open, and close. So we open and we grab a beaker, and then we close the drawer so no one trips on it. All right, okay? And then, guys, now we've got our beaker. That was step 11. Now, guys, step 12, this is tricky. Step 12 says, fill the 10 milliliter graduated cylinder with the acid and record the volume. Now, guys, these are your graduated cylinders, but they are magic graduated cylinders. Where'd my graduated cylinder? Oh, over here. Guys, you understand that with a graduated cylinder, you can measure a little or you can measure a lot, right? These graduated cylinders have two options, empty or full. So this one is 5, this one is 10, this one's 25, and this one's 50. So you are going to fill the 10 milliliter graduated cylinder. But guys, here's the thing that's weird. It's the opposite of the burette. So you're going to grab the HCl bottle and you're going to move it not to the 5, but to the 10. And again, you sneak up from below. But guys, you'll notice that it's not filling. It's taken the bottle from me, but it's not filling. What do you have to do to get it to fill? Let go. So next to this one, you want to write let go. And then it'll fill the graduated cylinder all the way to the top and then put it back. There we go. So now we have filled that graduated cylinder by letting go. Then, guys, step 13, pour the acid into the beaker. Again, sneak up from the bottom and let go. Then, guys, step 14, ready for this? Put the beaker on the stirrer and turn the stirrer on by clicking on this button. It even shows it stirring. That's pretty good. Then, guys, this is another glitch in the software. The next step, which one are we on, 15? You want to put a star next to number 15. Don't forget number 15 or you're going to get in trouble. Guys, number 15 says this, put phenolphthalein indicator into the beaker. Now, guys, over here on the right, these are all your indicators. This one right here is the phenolphthalein. So here's how you do it. Let me zoom out just a little. What you're going to do is you're going to grab the phenolphthalein and it gives you the dropper. Now, guys, watch and listen very carefully. Sneak up on this from the bottom, and again, it takes the dropper away from your hand. But what do you have to do to get it to add? Let go. But guys, watch and listen. When I let go, nothing. There's nothing that would tell you that you successfully put the indicator in the beaker except for one subtle thing changed. Do you see it? All of the other indicator labels grayed out. If you understand the idea of graying something out, it means it's no longer an option on a computer. So guys, all of these grayed out, and that one did not, telling you that you successfully added the phenolphthalein. All right, so now here we go. So we are now done with step 15. Guys, 16 says this, carefully add base to the acid until it first turns pink. And then, guys, step 17, record the volume. So, guys, watch. Here's how you do this. What do we have to do to get this stuff to flow? Turn the handle vertical. So turn it vertical and it flows. Then guys, in order to shut it off, they actually offer you something tricky. You can shut it off by moving it back to horizontal. But the other thing that you can do is double click in the middle. That works better. So when you open this up, double click in the middle and it shuts off. Now, in order to add this drop by drop, you can do this. I would say that's a pain in the butt. The other thing you can do is just move this down a little and it adds it slowly drop by drop. But guys, all the while we've been doing that, look what happened over here. This volume has been going down as we're adding base. So now guys, watch both. When we open this up, the volume drops and we can shut it off by double clicking, right? So how will we know when we've added enough of this to this? It'll turn pink. So guys, here's what you do. You open this up and you let it flow until it turns pink, and then when it turns pink, you double click in the middle. So here we go. Open it up, wait for it, watch for it. Oh crap, I missed. But guys, guess what? That's actually good. Here's the way you do these. What I just did there was not a mistake. You always titrate things twice. The first time you titrate it, you have done what is called a gross titration. And I don't mean gross as in disgusting. What that means is gross means not very accurate. So the first time you do it, you just do it really quickly and you go past where you should have stopped. So look at where we're at. If you go over here and look at this window, we are at about 10.5 milliliters. 10 is up here, 11's there, it's about 10.5. So what you do is you subtract about 1.5. So that takes us back to 9. What that tells us is we can safely titrate down to about 9 milliliters, and then we have to go really slow because we want to be accurate. So guess what that means? We've got to do this over. And you're going, seriously? Yeah, watch how fast this goes, guys. Right here is the trash. All that you have to do is this. Click on the trash can and it throws everything out. Then all you've got to do is set this up one more time. And guys, look at how fast this goes. Into the stock room, grab the acid, grab the base, go back out, bring them into the lab, like so, grab a beaker, close the drawer, put the sodium hydroxide in the burette, put the HCl in the 10 milliliter graduated cylinder, pour that in here, stick this here, add phenolphthalein, turn this on, get the viewer, you're ready to go. That's it. So now guys, what did we say we were going to go down to? 9? Okay, so let's zoom in here so you can see how this goes. And let's drain this down to 9. And you got to be quick. It's always better to stop a little early than wait too long. Didn't turn pink, so we're okay, right? Then what we're going to do, guys, is we're going to let this add drop by drop, being super ready to double click as soon as we see pink. So here we go. Drop by drop, it's going in. Done. That's it. I caught it exactly at the point where it turned pink. And guys, we are now done titrating. So notice what it says in step 17. Record the volume. And guys, this is the volume. How would we record this volume? So this is 9, this is 9.1, this is 9.2, this is 9.3. What's that? 9.28? Yeah, so 0.5 is there. 0.7? Yeah. So what about 9.27 milliliters? So guys, where does that go? That goes right here. Our volume of the standard is 9.27 milliliters. Now guys, forgive me, I forgot during the lab to do this. If you go back up to step 12, it says fill the 10 milliliter graduated cylinder with the acid. We forgot to record the volume. That's our unknown, right? We don't know the concentration of the acid. What was the volume of the acid? 10 milliliters. But guys, remember with our graduated cylinder, we always measure tenths, estimate tenths. So we'll go 10.0. You good? Okay, so guys, that's it. That's all we need. And given this data, we can now figure out the concentration of the acid. Those are the calculation steps. Check out your notes, and we're going to go through these 4 steps and show you how to do the math. So guys, what's step number 1? Balanced equation. Ready? Our acid is HCl. Our base is NaOH. Guys, reviewing for the SAGE test, what kind of reaction is this going to be? Double displacement. Hydrogen hooks up with hydroxide and it makes water, which you may also want to think of as being HOH. And then the Na hooks up with the Cl and it makes the salt that we call salt, sodium chloride salt. Okay? Now we need to balance it. We've got 1 hydrogen, 1 hydrogen, 1 Cl, 1 Cl, 1 Na, 1 Na, 1 OH, 1 OH, and that is balanced with all ones. Guys, and remember that trick. If you're balancing waters, many times it's easier to write water as HOH, and then I just like to get rid of it because it looks weird. You good? Okay. Now, guys, this is going to sound familiar. What's step 2? Moles of what? The moles, do this with me, moles of standard. Which one is our standard? The NaOH, right? And this is going to be dimensional analysis. Now, guys, watch. This is going to sound familiar. We know 2 things about the standard. We know its concentration. That's what makes it the standard. And we also know its volume. So we know its volume and we know its molarity. Remember when we did moles conversions, molarity conversions? Which one do we never start with? The volume or the molarity? Do you remember? Molarity. You never start with the molarity. So we are going to start with the volume. 9.27 milliliters, and we're going to convert that into moles. So guys, what do we do first? Milliliters to liters. 1,000 milliliters is 1 liter. Then, guys, just like before, how do we go liters to moles? Is what? It's molarity, right? This thing. So 1 liter is 0.1104 moles of NaOH. So now, guys, we do the math. And I know you know how to do this math, but trust me, there's something else you need to learn. Do the math. Grab your calculators. 9.27 divided by 1,000 times 0.1104. Now, guys, watch. Before you write down the answer, please see this because it's going to throw you for a loop. How many significant digits do we get in our answer? How many are here? 3. How many are here? Perfect. How many are there? 4. So how many should we get in our answer? 3. But guess how many we're going to use? 4. Here's why. This is brand new, guys. Hear this. Here's the deal. This answer is not the end. When we get this answer, it's actually another step in a bigger process. And so what that does is it makes this what is called an intermediate solution. And because it's not our final answer, there's another significant digit rule that you need to learn right now. The rule is this: you always figure out how many significant digits you should get and then add 1. So instead of the 3 significant digits we should use, we are going to use 4 and then round off the extra significant digit at the end. So instead of 3, we're going to use 4. So it's 0.001023 moles. That's an extra significant digit. Now guys, step 3, bring this down. 0.001023 moles of NaOH. And step 3 says the mole-to-mole ratio of standard to unknown. And our unknown is the HCl. Now guys, little SAGE review. Where do we go to get mole-to-mole stoichiometric ratios? Where do we find mole-to-mole ratios? Balanced equations. That's why we did this. 1 to 1 to 1 to 1. So 1 mole of NaOH and 1 mole of HCl. And guys, this won't always be 1 to 1, but now it is. And so that means the value doesn't change. 0.0010. No, that's a mess. 0.001023 moles of HCl. All right. Now, guys, step 4. You ready? Molarity is equal to moles divided by liters. We're now ready to figure out the molarity of the unknown. So to figure out the molarity, we need to know how many moles of HCl we had and how many liters of HCl we had. Well, guys, how many moles of HCl did we have? Right there, 0.001023 moles. Now, guys, how many liters of HCl did we have? 10 milliliters. But, guys, we've got to convert that to liters. So how do we convert milliliters to liters? Divide by 1,000. Still keeping 3 significant digits, because this is 3 significant digits. It's 0.0100 liters. Now, guys, let's talk significant digits before we do the math. You ready? Guys, follow this through. Make sure you don't miss this. How many significant digits are right here? 4. But it's really 3 plus 1. How many significant digits are here? 4, but it's really 3 plus 1. How many are here? 3 plus 1. How many are here? 3 plus 1. How many are down here? 3. So how many do we get in our answer? Well, now we round off the extra one. So this is 3 and this is 3. So our answer will be 3. So 0.001023 divided by 0.01. And to 3 significant digits, we get 0.102 molar. Do you get the idea? Now, guys, check this out. What has a molarity of 0.102 molar? The acid. We pretended like we don't know the concentration of the acid. But guess what? We really do know the concentration of the acid. We're saying it's 0.102. Guys, check it out. It's actually 0.103. We are off by a thousandth of a molarity unit. That is amazingly good.
Guys, here's the thing that's cool. When you come back and do this with me in AP Lab, we will use all of this glassware. When I'm going to teach you some tricks in lab, we can actually get accurate to 5 decimal places. 100,000, right? 10,000, 100,000 of a molarity. It's amazing how accurate this can be. Even in our labs, we can do this very, very, very well. So, guys, there you have it. Any questions about the process? Any questions about the math? Any questions about what you're going to do in lab on Monday? You guys all okay? You're good? Okay. So guys, we have 27 minutes. You have the homework in front of you. This is what we're doing today. So guys, dig in. You may get this done, but understand this is what we're going to do for the next 25 minutes. When the bell rings, we'll do Pride and go over the announcements. The answers are on the wall. And Taylor, it looks like you're leaving 1 minute ago. So guys, dig in. I'd love to help if you need, and that'll do us. No, you haven't.